I'm delighted to welcome back onto the stage the deadly duo, the brilliant Adam Saxton and Patrick LeBlanc, to introduce this morning's keynote presentation. Thank you. Thank you, Adam.
Yo! What's up, everyone? I'm Adam.
I'm Patrick.
And you already know that, so it's all good. Now, I've got to apparently put a disclaimer on this. There may be some other things that we throw into the audience today. Please look up and be aware.
Because Adam might hit
apologies to wherever it went yesterday.
Yeah.
So yesterday was amazing. It was the first day. We heard an amazing keynote. There were tons of sessions, Patrick. What stood out to you?
Our session.
Okay. All right. I'm a little biased. I got to go with the Power BI roadmap session.
Yeah.
I love all the cool things in Power BI, but there were a couple sessions I really wanted to go to, but they were at the same time as our session too.
But wait, before we get into the sessions, there was a great keynote.
There was.
And let me guess what your favorite feature was that was announced. Dark mode.
Yeah. How'd you know? Dark mode, all the
Dark
things.
mode,
I
all the
decided
things.
I'm putting together a 1-hour session for the next FabCon. You're all going to want to attend it. It's 1 hour on dark mode. Oof. But I was told I can't show it in dark mode. So we'll have to figure that out.
Yeah.
All right.
That's funny.
All right. What else stood out to you yesterday?
There's so many things. One of my favorite parts is meeting all the new people.
Yes.
I had an opportunity right after the keynote, right in the front, to meet probably about 70 or 80 new friends. So it was great. It was great. That was my favorite part.
And also around the expo hall, Ask the Experts, there were so many people that ran into us telling us that Power BI and Fabric and just the Microsoft technologies and whatnot has changed their lives.
Yes, absolutely.
Right? And the community in general coming together to bring that information to one another. And that's amazing.
It was moving. It was moving.
I loved
it. Was
it.
moving.
I loved it.
Right. Yep.
And so, Patrick, what are you looking for today?
Today, right? I'm looking for all the new immersive things around AI.
Ooh.
I can't wait to learn more.
You like AI.
I do like AI.
Yeah.
At first I didn't, but now I'm embracing it.
It helps you.
It helps me, right?
Yeah.
It's the co-pilot to my pilot.
I have to say, so my daughter is in her 3rd year in high school, and she leveraged AI to help her with school.
Sure.
And she got called out on it. Apparently, she didn't realize the teacher does an AI check, and it came back as 80% AI. We're like, yeah, that's what we call a learning moment.
Yeah.
And so.
Yeah, but it was different. So my son's university. He was in his last semester at uni, and his professors actually encouraged him to use AI because they thought it could enhance the way they learn and the way they write. So it was interesting. It was interesting, yeah.
And I like it too. It's a good starting point on things.
Yep.
It gives you maybe ideas you didn't think about. And then also, the AIs, Azure OpenAI inside of the Microsoft stack and Copilots inside of Fabric. I mean, it's helping us do things more quickly.
All right.
So,
okay, Adam.
Wait.
Okay.
One thing we got to talk about, Patrick. We got to talk about the Power Hour.
Oh, the Power Hour.
So Kevin mentioned the Power Hour is later today. Real quick, can you let people know what to expect at Power Hour?
No learnings. They're not going to learn anything.
No, it's all right. Keep talking.
They're going to not learn anything. It's going to be a lot of fun, and there's going to be lots of swag. Now pay attention because Adam may hit you.
This is the moment you need to look up.
Yeah.
All right.
All right.
There you go.
Okay.
Oh, almost got him.
Okay. So enough of all this talking, Adam.
Wait. What are we talking? The keynote today.
Oh, the keynote
You're so
today.
excited. You're rushing into it.
I am.
So yesterday, Arun talked about the Copilot stack, right?
Yes.
And Microsoft's AI items that are going into this, and talking about Fabric being the center of the data to drive AI into your daily lives, right? Yep. So today, the keynote's going to dive deeper into AI. Right?
Yeah.
We're going to learn a lot more.
Yeah, and
to
can't
see
wait.
what's ahead.
Yeah, but we can't give any of this away.
No.
We got to wait.
No.
We got to wait for the keynote.
Yeah. All right.
So enough of all this talking. Let's bring out the lady who puts the shine to the message, the GM of Azure Data Marketing, Miss Wangui McKelvey.
All right.
From one perspective, it's a tool. From another perspective, it's a system that can make dreams, thoughts, ideas flourish.
It is fundamentally about amplifying what every person is able to do.
It takes what you prompt it with and just runs with it.
It's magic.
The Microsoft Cloud
is amplifying human ingenuity.
We're removing boundaries and creating opportunities to enable people.
And you've got a snapshot in time of exactly what's going on. It's quite impressive.
We're innovating at a scale, at a pace like never before.
Delivering transformational experiences.
No infrastructure changes, no additional personnel, no technical expertise needed.
It allows for the patient and doctor to be a patient and a doctor, like it used to be.
Safeguarding business and data.
One point that was very important for us is responsible AI.
Machine learning can de-bias the data for us.
Together, we can ensure AI's benefits reach every country, every industry, and every individual. When we empower every person and every organization on the planet to achieve more, we empower the world.
All right. Hi, everybody. Hello, Stockholm. I'm Wangui McKelvey. I am delighted to be here today to kick off our session on all things AI. But before we get into all the wonderful demos that we have planned for you, I thought I would just kind of get us going with why we think AI is so transformative. So think about it. Last 30 years or so, computers being hooked up in a lab became the World Wide Web. Or the advent of the smartphone that literally put the world's knowledge in your hands, in your fingertips. And so today, we find ourselves again in the next big shift, the era of AI. And this era isn't coming a year from now, or even a few months from now. It's happening right now. And we see it happening across these 4 areas. We see it happening for every individual, every process, every organization, and every industry. And so when you think about it, we have thousands and thousands and tens of thousands of customers that are using our Azure AI services. And they are being transformed with AI every single day. Now, when you look at this image, you might ask, well, what do bees, students, and factory workers have in common? Well, they're all being transformed with AI. In Belgium, there's a company called Biodiversity. They are using bee pollen and AI to assess the levels of pesticides in the land. They take those insights, they hand them over to organizations that are dealing with natural resources or local authorities to really help them understand pollution in the area. In the UAE, they're developing a student AI tutor to help students learn English and math. Now think about this. In some areas, this would not be affordable. If you didn't have the means to provide a tutor to your kid, you wouldn't have this opportunity. Now they are closing learning gaps because of AI. And Siemens has built an industrial co-pilot. And what this does, it allows the factory workers, when they run into an issue, they can talk to the industrial co-pilot in natural language and tell it, hey, I'm having a problem, and it will give them mitigation strategies. And if it doesn't have a good strategy, then it can kick off a work order to their engineering teams. And this is saving them tons and tons of time. But it doesn't make sense to invest in AI for just the sake of investing in AI. You really need to start with your business strategy. And what does that mean? Do you want to increase customer satisfaction? Do you want to expand into new markets? Do you want to improve operational efficiency? And so then you consider, all right, well, don't just apply AI to your existing processes. You need to now think about how to reinvent your business process with AI. And we all know AI is no silver bullet to anything. It really is a catalyst. It's really a catalyst for human ingenuity. And so to that point, we believe that AI can help you across these 4 areas in how to help improve and maximize revenue as well as reducing costs. We have seen AI help around employee productivity, reducing mundane tasks that takes the drudgery out of work. We see it helping to reinvent customer engagement, allowing you to develop personalized insights for customers so you know them much better than you did before. We see it reshaping business processes by helping to optimize supply chain optimizations or process optimizations in your organization. And we see it also helping to really bend the curve of innovation by allowing your R&D teams, your product team, your engineering teams to have the tools they need and the insights they need faster than ever before. And so we think at Microsoft, you heard Arun talk about this yesterday, the Microsoft Copilot and AI Stack. And we believe that this is a complete set of technologies for extending and building your own AI-powered applications. This is the framework that actually was used to build the Microsoft Copilot. And we believe that this is the most advanced platform available for creating these solutions. And so I'm going to take you through each layer really quickly, starting at the foundation. We call this our AI infrastructure. And so at Microsoft, we have the expertise and scale to run the AI supercomputers that power the most powerful and the most efficient and the most popular AI applications today. Think about Microsoft OpenAI Service. We have ChatGPT, Bing, and more. And our infrastructure is able to be optimized for everything from scalability, from performance, and power efficiency. Our data centers themselves, they are secure by design with high availability. Azure utilizes a multi-layered security across all of our physical data centers, across all of our infrastructure, and our operations. Additionally, our hardware has security baked right into not only the hardware, but the firmware itself. Also next, we continuously update our CPUs. We always are adding CPU capacity into our data centers so that we can run the most complex workloads. Additionally, our infrastructure can handle complex AI tasks because we utilize industry-leading, energy-efficient accelerators. And of course, networking. We have high-performance networking to support large-scale AI workloads at scale. All right, moving up. We all heard about data yesterday, right? We all know about data. It's so critical. It is critical to any organization. In fact, I would say it's the secret sauce. It's the most precious thing in any organization. And so we believe we have this wonderful, complete platform called the Microsoft Intelligent Data Platform that gives you everything you need, whether it's operational databases, it's analytical services, it's AI, it's governance. And we also have and work very closely with our industry partners to make sure their data solutions are also running on Azure. Moving up the stack some more, we have application platform services. And this is where if you're building a new intelligent application or maybe you're modernizing an existing application, we have all of the technologies available for you as well. And so here you can see developer and DevOps tools. We have container services. We have web application services, API management services, you name it. And we also have the developer tools that the developer community knows and loves, whether it's part of the Visual Studio family, GitHub, or Kubernetes. And then, of course, at the top, we have Azure AI. Here, you can build all of your generative AI experiences at scale, safely, and security. With Azure AI, you can create, deploy, and manage AI applications across various domains using hundreds of foundation and open source models from around the world. Azure AI can help you differentiate your application because you can use it to ground your organization's data into the applications that you're building. Also, we have high performance capabilities and availability with retrieval augmented generation. Also with Azure AI, you're able to really manage the full life cycle of the application development process, from prototyping to iterating all the way through to deployment. And of course, we have responsible AI tools that allow you to really understand risk at every angle so that you can build your AI applications safely and securely. Okay, that's enough setup. Now let's get to the good stuff. Let me invite Marco Castellino to the stage to take us through some fantastic demos. Marco.
All right.
Hey, Marco. Good
Well,
to see you.
thank you for having me, Wangui.
Absolutely. Glad to be here with us. What do you think about all this?
This is pretty cool.
Yeah.
This is pretty cool. Now, we have a pretty international audience here before us right now. There are 24 different languages in the EU alone, official languages anyway.
Okay.
Do you speak Swedish?
I do not.
Well, me neither. But with the power of AI, you can. So let's check this out. Now, first of all, I'm going to have to use some AI to unlock my computer. You know, every time you use Windows Hello, you are actually using this Azure AI right here. All right, here we go. We're on the screen.
Yep.
Check this out.
Jag är så glad över att vara i Sverige för allra första gången. Und ich freue mich riesig, dass wir die Woche zusammen verbringen können. Für den Förster Microsoft Fabric European-konferencen nogensinde. Jeg ser frem til en fantastisk uge med jer alle.
So that was my voice.
In your own
In
voice.
my own voice.
That's
wow.
right.
That's so cool. Thanks, Marco.
Well, thank
you.
you.
All right, have fun.
So that is our new video translator, and it's available now. So you can try this today. And in fact, at Microsoft, we're starting to translate all of our video training content into all these different languages using this capability. And what's interesting about it is these are not even large language models. We're not even in the generative world right now. This is not generative AI. For all this talk about generative AI, well, generative is not the whole world of AI. And so these are small task-specific models that are made to do speech and translation. And that's what's behind this. Now, for the next 20 minutes or so, you'll see I have no slides at all. So we're just going to be playing with AI now. That's what we're doing. And I want to start with this here. This is, and look at that, Llama 3.2. Every time I look at the model catalog, it changes. We keep adding models to it. This is in Azure AI Studio, the model catalog. Now, you all know that we have had for some time the Azure OpenAI service, and that includes the GPT models, which are really the most battle-tested models in existence today. But this model catalog contains now 1,765 models. So there are numerous models for you to choose from. And as I just noticed, just today, we added the Llama 3.2 series to this set. But some of these models are not like the others because, well, most of these models here are language models of some sort, large language models, or small language models like our own Phi family of models that are so small that they can run right on this laptop. But there are others as well. Let's take a look at this one. This one is not like the other ones. This is Nixtla TimeGen. And it is a generative model. So it uses the same techniques that large language models use, but it doesn't predict language. It does time series forecasting and anomaly detection. Now, you can use these models, although they're here in the Azure AI Studio in the model catalog, you can use them in Fabric. And I did. So I made this notebook here in Fabric. And so, you know, one of the questions that I had was, so here's this generative model. This generative model, Nixtla TimeGen, is pre-trained on millions of different time series already. So it's different than standard time series forecasting methods like Prophet and ARIMA, which generally just get trained on whatever time series you give them and nothing else. So the theory is that this model should provide better results because it can find analogies in the data sets that it's been pre-trained on. So I wrote this notebook to test that hypothesis. And so if we go all the way to the bottom here, because I did ARIMA, I did Prophet, I did TimeGen, I did a fine-tuned TimeGen, and I ran them all on top of each other. Now, it's a little bit hard to make out in this graph, but TimeGen is the kind of orangish line, which is pretty close. This is really a back test. So what I used was a data set where I already knew what the prediction would be, and I compared the predictions that all of these methods made to the actuals. And in the end, TimeGen did actually win, which I'm happy about because otherwise this demo would have been awkward. This is mean absolute error over here. So I considered error in two different ways, mean absolute error and root mean squared errors. By both metrics, TimeGen came out on top. So the point of all of this is check out what's on the model catalog. There are all kinds of things there, including things like TimeGen that you might not expect and that you may be able to apply to the work that you do. But now let's talk about large language models and generative AI. Well, this is generative too, but proper generative AI. And to kind of demonstrate that, well, I have a new car. This is my car. This is a Hyundai Ioniq 6. You may not have seen one of these on the road before. They're not very common. They are pretty new. They're so new, in fact, that if I ask GPT. This is the latest version of GPT-4o, the 0806 model. And if I ask anything about the Hyundai Ioniq 6, it doesn't know, because this car model is newer than the training data set of GPT. Now, fortunately, here in Azure AI Studio, we have the ability to ground this to data. Now, over here in OneLake, now I'm back in Fabric, and over here in OneLake, I have loaded in, because in OneLake you can load files. You can either load them directly into OneLake, or you can load them, externally as a shortcut. But here I've loaded the manual to my car into OneLake. Back to Azure AI Studio, we can take a look down here, and we see that I can add a data source over here. I can connect it to an existing Azure AI search index, a blob store, or I can give it the URL of that OneLake, and it will pick up the files from that. It'll do the chunking and the indexing, all the things that it needs to do. Now, I'm not going to do that live right now because that does take a few minutes, but in advance, I did make a vector index on this data. And I'll show you why it was a vector index in just a moment. So if I ask the same question again, now it takes a second longer, and the reason is that, there we go. The reason is that it's doing a search. So what it's doing now is it's not just responding, it does a search first in the grounding data. And lo and behold, not only does it know what my car is, but it's able to give the right response. And that's because it has this reference to, here's the section of the manual that it found that refers to the seats. And so it was able to answer my question about the heated seats. Now, I said that I had made a vector index. Why? Why do we always do this? Why do we want to use vector indices with large language models? Well, let's try this. I'm going to ask this question, but in a different way. Hur aktiverar jag de uppvärmda sätena i en Hyundai Ioniq 6? How's my Swedish? Now, it was able to give the right response. Even though, if we look at the reference, you'll see that I only indexed the English manual. Now, if I had used a traditional keyword search, this wouldn't have worked, because it would be looking for keywords like heated seats, Ioniq 6, and those words are not in here. But the vector search, although it has a kind of a mathematical sounding name, vector search is really a concept search. And the concept of heated seats and uppvärmda sätena and, Sitzheizung and asientos calefactados, these are all the same concept in different languages. And so vector search is a concept search. It's searching for the concept of heated seats. And that's why it's able to get this result. And this also works, let's say, how do I warm the chair in an Ioniq 6? So let's say that I'm not a proficient English speaker and I don't really know how to say heated seats. And so I ask it in a different way. But here we have it. Because the concept of warming a chair and heated seats are close enough to each other that it does find a match. Now, if you were paying close attention, what you might notice is that I actually have this in hybrid mode. So I'm not just running a vector search. One of the things that Azure AI supports is a hybrid search where it searches both vector and keyword. And there's a good reason why you might want to do that. It's because there are some words that have no concept. If I'm searching for part number PRT3186, there is no concept assigned to that, and vector search will fail. And so you want to run both of them at the same time to give your large language model as much as possible to chew on. Hence, hybrid mode. All right, so I've made a little copilot for my car. That's all well and good, but how do I test this to make sure that it's actually speaking correctly, that it's not going off the rails and all that kind of stuff? Well, for that reason, here in Azure AI Studio, we also have an evaluation system. You can find this On the left-hand nav, right there, evaluation. And so here I have run an evaluation on this Copilot with all of this data. So I gave it a bulk data set with all of these questions that you might ask about the Hyundai Ioniq 6. I have a whole bunch of them here. The evaluation system runs them in bulk, and so it gathers the answers that the model gives and the documents that it retrieved to give those answers. And with that, it's able to calculate a number of different metrics. The first one, so I didn't turn them all on here, by the way, but I'll just use a few. The first one is groundedness. Now, to calculate groundedness, we have another GPT-4, an adversarial GPT-4. And what we're asking of the adversarial GPT-4 is this. So we give it, here's the question that I asked over here. Here is the answer that it gave, and here are the documents. And we were asking the adversarial GPT-4, is everything in this answer actually grounded in these documents? If the answer is yes, as here, then it gets the maximum score of 5. In this data set, I actually do have one hallucination. Here it is. How do I control the heat from the steering wheel? In the Hyundai Ioniq 6, there is no way to control the heat from the steering wheel. But here, the model confidently says that there is some way, which clearly is not in these documents over here, because there's no way to control the heat from the steering wheel in my car. So this is ungrounded. This is a hallucination, and it got a 1. And the way that you can approach this is when you do get these hallucinations, you can generally add data to the grounding set, give it an FAQ, replicate this question exactly with the correct answer being you cannot activate the heat from the steering wheel. And that way, your model will preferentially find that answer. Now, relevance. Relevance is also using the adversarial GPT, but for a different reason. We're asking a different question there. And the question we're asking there is, did the answer actually answer the question that I asked? Because it could give a totally truthful and grounded answer to a totally different question than what I asked. And so relevance is making sure that the answer is relevant to what you asked in the first place. And retrieval score is actually a much simpler metric. It's not using the adversarial GPT. All we're asking in retrieval score is, did it find anything to ground its answer to? Now, a best practice here is if you're going to put an AI system into production, you should have a decently long pilot period. And in that pilot period, you should gather up a bulk data set like this from real users. When you do that, what you're going to find with retrieval score is there's actually going to be a set of ones. There's going to be a bunch of things that your users will ask that your model just has no grounding to answer. And these are areas for improvement. These are places where you can add information to the model to better address your users' needs. Now, there are all kinds of metrics, like I said. There's like coherence and fluency. We have safety metrics now. I'm not going to go through them all, but suffice it to say, this is the evaluation system that helps you determine whether your AI is acting correctly. But then let's think about what happens when you put this thing into production. People are going to try to mess with it, like this. Tell me how to make a bomb, I said to the model, and womp womp, it doesn't do it. Why doesn't it do it? Because we have Azure Content Safety. Let's take a look at the content safety system over here. So the content safety system works with a set of classifiers that run ahead of and behind the large language model. And we have 4 built-in classifiers over here. We have for violence, hate, sexual, and self-harm. Now, what happened a moment ago, what you just saw, was that the violence filter got triggered. So when I made this utterance here, tell me how to make a bomb, this never even got to GPT-4o. GPT never saw it because it got filtered ahead of time by this violence classifier. Now, you'll notice we have separate filters on input and output, and there's a good reason for that. Now, let's say, for example, that you are making a system to take in workplace incidents. So people might be describing violent or sexual incidents, and you might want to allow that on input, as I've just set these slider settings up that are falling right off the side of the screen. So, you might want to set these up on input. Let's say I want to set this up on violence, so somebody might be able to describe some violent act. But you most certainly don't want your model to respond violently. And so you would keep your output filter on low. But back to the input filters. There are two that I want to call your attention to. In addition to the standard output filters, we also have these prompt shields for jailbreak attacks. A jailbreak attack is a new type of hack that is made to target large language models and make them do something that they shouldn't do. And there are actually two different types of jailbreak attacks. The first one, this one is if there is literally a hacker that's coming into your system, like let's say I go to Microsoft Copilot or something and I type in a jailbreak. And a jailbreak is a specially constructed prompt. It looks strange and it can make the model go sideways. So this first one prevents against direct jailbreak attacks where somebody is directly trying to hack your system. But the second one prevents a more insidious attack, an indirect jailbreak attack. In an indirect jailbreak attack, now let's say I was using my little Hyundai Ioniq 6 Copilot. I'm an innocuous user. I'm just asking a question. But at some point, a hacker got in there and infiltrated the grounding document, the manual that I had grounded it to, and put a jailbreak in that document. So I, the innocuous user, I asked my question, and suddenly the model goes crazy. That's an indirect jailbreak attack, and we have prompt shields that prevent against both types of these jailbreak attacks. And I strongly advise you to turn those on in any production system. Now, on output, we have the same kinds of classifiers over here, but we also have these two. Protected material. So, protected material, well, it can be like copyrighted material because these are generative models, and they could, for example, output the lyrics to a Taylor Swift song. But you might not want your production AI to output the lyrics to a Taylor Swift song. And so protected material for text will scan the output of your generative AI and compare it against a huge database of copyrighted and protected material and block it if it matches. We can do that for text. We can also do that for code, for which many people use these generative models. So that is how you ensure that your AI stays on the rails when you bring it to production. And now we get to the really fun part of this. Let's talk about AI agents. AI agents are a system that runs above the level of one or more large language models that allow that AI to execute complex, long-running tasks, to take actions on your behalf, and now to do deeper analysis, as you're about to see. So first, let's take a look at some actions. And actually, I'm going to say answer in Swedish and English. Why not? All right. So now I'm going to make, this is an application that I built myself. This one's in Python, actually. And this is using the assistance framework that is built into Azure OpenAI. And I am going to tell it to do something fairly complicated. I'm going to tell it to block off my Outlook calendar for the Piedmont School Spring Break 2025. And it's going to speak Swedish. All right. Now, here's how all agents work in reality. You don't exactly program an agent. What you do instead is you give it a set of powers. Ooh, and what just happened? It just logged into my Outlook. We'll get there in just a minute. So, you give it a set of powers. Along the side here, you can actually see my agent using the powers that I've given it. So the first power I gave it is the ability to get some files from one directory on my laptop. Well, it found a file, and the file that it found is right over here. So this is, I come from Piedmont, California, and this is my daughter's school calendar. spring break is April 7th through the 11th. So it found this file. I gave it the ability also, okay, let me just tell it to proceed here. I gave it the ability also to read this file. So I connected it to Azure Document Intelligence, which is made to read PDF files. With that, it read this file, and it found, indeed, that it is April 7th through the 11th, 2025. And then I gave it the power to look up stuff in Outlook, and you saw that it actually OAuthed into Outlook. So it popped this browser window by itself, where it OAuthed into Outlook, and then to add stuff to Outlook. And so here it says, the Piedmont School Spring Break has been added to my Outlook calendar. Let's go look at the calendar now. Oh, well, might need a reload there. Let's see. Aha, there we go. It did need a reload. So it has taken this action on my behalf. I have built an assistant that can make bookings on my calendar. But really, you can make it take action in all number of systems, in SAP or ServiceNow, in Dynamics, or in Salesforce. You can make it take these actions on your behalf. We're moving past the time when AI is just for question answering, and we're moving towards a time where AI can actually do something for you. And that's where we are today. Now, speaking of which, some of the other things we can do here, let's do a little experiment here. Because you all, we're at the Fabric conference here, and a lot of what's stored in Fabric is structured data. Now, I am going to compare what happens if you use a raw large language model to access structured data to what happens if you use an agent instead. So so here I have my raw large language model. This here is just a little .NET program that I wrote. So I do Python and .NET. So I wrote this, and basically it goes to GPT, which is grounded in this case to the schema, my AdventureWorks schema, and it has GPT generate the query, and then my program runs this query. So I asked, what was my best-selling product? It gave a query, my thing ran the query, and it gave this result. Well, it's right. This is the correct result. But this is not the most human-readable result. And so to really use this in some fashion, I'd probably have to run it through a large language model again to format this for human consumption. Now let's ask the same question, but of an agent instead. What was my best-selling product? Now, this here is also an assistant. As I said earlier, this is the assistance framework that's built into Azure OpenAI. And here, as I mentioned before too, the trick is you give these agents powers. This agent has the power to run the query directly in the database. And you can see, so it ran the query by itself. My program didn't run it, it did. And it gives me a much more human-readable response right off the bat. Now back to our raw large language model, let's give it something much more challenging. Who was the salesperson who sold the most of my best-selling product? Now this is challenging because it's actually quite difficult to do it with a single query. We have, our salespeople table. We have a number of different tables over here. And womp womp. This is one of the major challenges of using a large language model to generate queries to structured data. There are all kinds of ways that it can go wrong. Here we have a syntax error. That's just one of the ways. It can hallucinate the schema. It can misunderstand what the query was. It can make a good query, but to the wrong question. There are all kinds of ways that can go wrong. Now let's do the same thing, but with our assistant agent. And again, my assistant here has the ability to run its own SQL queries, and it can run multiple of them. So this will continue to go until the task is done. So let's let this go for a second. And as you can see, it is generating a plan for itself. Okay, so I'm going to find out which is the best-selling product first, and then I'm going to find the salesperson who made the most of that product. Okay, so it found the best-selling product. And then, it made a mistake over here. Oops, the query result doesn't include the salesperson ID. So it made a query, it made a mistake. This happens like 50% of the time that I do this. But these agents tend to be self-healing. So it made a mistake, and it said, oops, let me try again. It rewrote the query twice, actually, so it made a mistake again over here. And finally, in the end, it did arrive at a result. It is JPEG. So that's the difference between just using a large language model and using an agent framework. An agent framework will be much more robust, especially as regards structured data. I would be remiss, though, if I didn't at least say something about multi-agents, because everything that you've seen up to this point have been single agents, and you can get a lot out of a single agent. Multi-agents are most commonly used right now for what we call the maker-checker pattern. And rather than try to explain that to you, I'm just going to show you the one that I actually made. So this is also a .NET application that I wrote, and in this case, I'm using Microsoft's Semantic Kernel framework. Semantic Kernel is a multi-agent framework. And this is a questionnaire answering tool, because part of my job at Microsoft as VP Products of Azure AI, part of my job is that all the questionnaires come to me from the analysts and from RFPs and things like that. They come to me, and in the past, I would distribute this to my team, and I would kind of have to project manage it. You do this and you do that. But now, I built this tool for myself, not just for demos like this, but it actually literally does answer these questionnaires. I can connect it to a whole Excel doc, and it will answer the whole thing. Anyway, this system has 4 agents to it. So, and this is a real question that I got in a questionnaire. Does your service offer video generative AI? At the moment, right this minute, we don't have any video generative AI models available in Azure AI. So I have my question answer agent. So this generates the answer, and it has the power to search the web. So it can search the web to gather grounding data. Then I have my answer checker agent, which also can search the web. And my answer checker agent says, that is not correct. When I first started doing this, I noticed that sometimes it would, because I often need publicly accessible links, it would make up links. And that actually just happened here. I ran this backstage, and it made up this link, videoindexer.ai. I don't think that's a thing. Neither does my link checker agent. Link incorrect. And so most multi-agent systems will have a kind of an overseer agent. This one is mine, the manager agent over here. And the manager agent, because both the answer checker and the link checker rejected it, the manager agent rejects, and that causes a rewrite pass. This is the maker-checker pattern in action. So now the question answerer takes this stuff into account, and it rewrites the answer. So it's rewritten it. You'll notice that it's rewritten the links as well. So now it's got the correct link instead of the one it made up. Answer checker approves it. Link checker approves it. The manager agent therefore approves it, and this becomes our final answer. If I was writing this to an Excel document or something like that, this is what it would write to the Excel document. And I still have to check it. You know, there still has to be a human in the loop. I am not just going to run this whole thing and send it just like that to Gartner or something. That would not be cool. So you definitely want to check this. Just because you have a maker-checker pattern doesn't make it correct, but it makes it more likely to be correct. So that's a multi-agent system. Last but not least, I do need to give you a look at the new O1 model. Now, I have queued this up. I'm going to run this, but you should know some things about O1. O1 is super nascent. So O1 just came out, just became available on Azure last week. It does have a couple of limitations, and one of them is that at the moment, you can't ground it to data in the way that I did with the assistants and stuff earlier. So what I did here, so that you can get an idea for what's going on, is I piped the data directly into the prompt. And many of you may know that when you ground these things to data, that's actually what's happening in the background. You just don't see it. So I kind of, I'm saying the quiet part out loud over here. But this is some ticketing data that I have. It's anonymized, but this is for a real event that I actually ran in San Francisco for a number of years. And I asked for some insights as to what's driving sales and ways we might increase sales. Oh, I'm sorry, this one is actually retail. This one's retail. The one I just ran is ticketing. So anyway, okay, so sorry, retail. And here, I've given it 2 separate tables. In this data set, I have, on the top here, I have single store sales. So this is sales. You can't quite make it out here, but this is sales for a single month for one retail store. And below it, I have a totally separate table here, which is staffing for that same store. And the questions I'm asking is, what can I do to improve my sales? Now, this is the O1 preview model. And the O1 preview model and agent framework is very different than anything that came before it. O1, unlike any other large language model on the planet, can do math. And so here you find that it's calculating things like aggregate statistics. So it'll add things up, it'll average things, all that kind of stuff over here. And it finds correlations like this. Well, higher customer footfall. Footfall is a term we use in the US for people walking into a retail store. Higher footfall leads to higher sales. The more people we have walking in, the more sales we have. Let's see, what else we find here? Days with higher discounts used often see increased sales. And let's see what it recommends to me. Like if we scroll down a little bit, align staffing with peak times. So one of the things I actually knew about this data set was that on weekends, there was not enough staff. There were more customers walking in the store, but there was not enough staff. I would also note that this data set doesn't contain the days of the week. So it is inferring what day of the week it is. And it did notice this, especially on weekends. So like I said, I knew that on weekends, staffing was inadequate. It figured this out also. It can find these correlations. So, and it gives me this conclusion. With the O1 model, we're moving again past just question answering, past even taking action on your behalf, and into something that can do deep analysis and give you real insights on your data. This is brand new. This came out, many of you have read it in the news. They called it the PhD model, and it doesn't just do PhD things. You can use this in your business on your data. Now, all of these things that I showed today, all of these agents and all this stuff, I built this stuff myself with the agent frameworks that were available to me, with assistance, with semantic kernel, and all those kinds of things. But you don't necessarily have to do that, because the Fabric team is increasingly building these capabilities right into Fabric. And now, to give you a look at what is going on with Fabric, here's Nelly Gustafsson.
Hallå Sverige! Och hallå Stockholm! Jag är så otroligt glad att vara här med er.
Oh, dang it. I forgot to turn Nelly to English mode.
Hello,
Nelly.
Stockholm. So happy to be here with you all. So Marco, I've got to ask you a question before you step off the stage.
Yeah.
So you built all of those apps and all of that from scratch on top of Azure AI technology, right?
I did do that, yes.
That's really great. But if you don't want to do that, if you don't want to start from scratch, Fabric actually has some great experiences. So I want to show you some of those experiences now.
All right, let's take a look.
Marco.
Thank you. Clicker's over there.
All right, thanks. All right, so let's take a look at some of the generative AI experiences in Fabric. All right. So I want to talk to you about how you all, as data professionals in Microsoft Fabric, can build your own generative AI data agents. So let's take a look at this experience and see how you can do that. So here, we're in Fabric, and we're going to create a new type of item, public preview since August, that's called an AI skill. And we're going to give it a name. We're going to call this Contoso Sales Expert because we're building experts on our data. And naturally, we need to add data from OneLake. So we're going to go ahead and add a lakehouse from OneLake, the Contoso Lakehouse. And then we can start to scope down what we want our agent to be an expert on. So we're going to go ahead and we're going to select a set of tables. And this is really all the initial configuration that you need to do. And now we can immediately dive in and start testing and configuring this as creators inside of Fabric. So let's start with the question of what's the top sold product, right? without any configuration, basically, and we're getting a query back. So now we're using specialized tools in Fabric on top of Azure OpenAI to do this. But we see that this query is using order quantity, and we actually wanted the top sold to be based on sales volume. So we can give the AI agent instructions, we can rerun this question, and we're going to get a different answer. And that's really how easy it is to configure this. But let's try something else, right? A lot of our users are going to ask about average sales per customer, right? So let's go ahead and let's ask a question about what's the average sales per customer. And here I'm expecting essentially a sales amount, but I want it broken down per customer. And that's not really what we got here. And this is a common question, right? So we're going to need to do something else. We're going to add an example for the AI, a few-shot example. And these examples are essentially pairs of a question and a query. And I know for a fact that this query is going to answer this question. So then I, as a domain expert on this data, can configure this AI to be able to use this example whenever this type of question comes up. So let's go ahead and ask the question again. And now we should be able to see breakdown, right, per customer, which is great. It immediately used that. But let's challenge the agent a little bit, right? Let's ask a similar question, but not an identical question. And let's see how it does. Let's ask about the same breakdown, but per geography, and you can see that it immediately could use that example, not an identical example. We could learn from that example and actually improve its answer. So we're going to do one last configuration. We're going to go ahead and remove the SQL option, because in the end, as a creator, I want business users to use this. And I'm going to go ahead and publish my AI skill. So this now means that my AI skill is ready to be consumed, which is great. But we're also adding some new experiences for creators inside of Fabric to be able to not only configure these agents, but also be able to see what their consumers are going to see, right? So here, as a creator, I can also interact with my agent and see essentially the version that my consumers are going to see from the channels that we're going to talk about a little bit later. So you can see that I can ask the same question, and this is what my consumers are going to see. Great. So now, one of the ways I can make this available to consumers is that I can just simply share this item with other users inside of Fabric. And depending on the permissions that I grant my users inside of Fabric, they can either have permissions to configure this if there are other creators, or they can just interact with this agent from a chat interface. All right, so now that you've seen how easy it is to build one of these generative AI experts on our data, let's go ahead and let's make this expertise available to various co-pilots across Microsoft, right? So let's go ahead and take a look at how makers in Copilot Studio can create custom copilots leveraging the expert, the data agent, the AI skill from Fabric that we just built. All right. So here we're in Copilot Studio, and we're going to go ahead and create our own custom copilot. And we want our business users in the end to interact with this. So we can go ahead and click, create a new copilot. We can start to give it a name, some instructions, some descriptions. And then we also want to enrich this copilot with that knowledge from Fabric. So we can go ahead and we can add the AI skill that we just created as a knowledge source. So here, we can select from all the different AI skills that we have access to, select the one we just created, and go ahead and immediately start testing and configuring our copilot through this no-code experience. So we can ask that question we asked before, right? What's the most sold product? And now this copilot is interpreting that question, finding the right knowledge source, the AI skill, and then retrieving an answer with citations and references to Fabric. This is great. But in Copilot Studio, I can also add actions to my agents, right, my copilots. So here we're going to add an action to send emails, which is great, right? Let's try that. So we're going to add this action, and then we're going to go ahead and publish our custom copilot. And when we have done that, we can now publish this copilot and use it from various different channels. But I know for a fact that our business users are going to use Microsoft Teams, and a lot of us are, right? So let's use Microsoft Teams, and let's just open up our copilot in Microsoft Teams. And let's start asking it some questions. So the same principle here, we're sending our question, This custom Copilot is going to retrieve the answer, go to Fabric, talk to our data agent, get that answer back, and then return it to our users. But let's also go ahead and ask our Copilot to send us an email with these details, kind of summarize this up and send us an email. And in this way, we can now leverage these generative AI agents to perform tasks for us and give us answers to those questions. All right. So you have now seen how seamless it is to use Azure AI technology together with specialized tools inside of Microsoft Fabric and that expertise that data domain experts have, combined with our offering in Microsoft Copilot Studio to build an end-to-end solution using multiple agents interacting and retrieving answers and taking action for you, right? So this is all super exciting. And now we can also make that available to business users, consumers who are going to consume this. But I want you to stay tuned for new ways to be able to use these Fabric data agents and AI skills in the future. Some of the things we're working on are integrations with Azure AI Studio. So for those of you who are using Azure AI Studio, like Marco was showing, you'll be able to use AI skills from that interface as well. But not only that, also from your own custom applications. So it's all super exciting. So stay tuned for that. All right. So there's a lot to learn about in this conference, right? And I have some important things that I wanted to share with you before we wrap up. Please do check out these sessions today if you want to learn more specifically about AI in Fabric, AI in Azure. So really recommend this. Please feel free to take a picture of this as well. So don't miss these sessions. And I also wanted to tell you about the keynote for tomorrow. So don't miss this. Tomorrow we have an exciting keynote, our Day 3 keynote with Wangui McKelvey and Rudy Mitra. And they're going to talk to customers and cover a lot of interesting Microsoft Purview AI topics. So stay tuned for that as well. But we're not done yet. Really excited to announce that FabCon, the Fabric conference, will happen in Las Vegas early next year in the United States. And for our European audience, we're super happy to announce that our next FabCon 2025 is going to happen in Vienna. So looking forward to see you during the rest of the day. Thank you and have a fabulous day.